Good evening, everyone. Wednesday, April 29th. This is for Algebra 2. We're going to talk a little bit about logarithms as inverses. Make sure you guys know what that means. Make sure you guys are capable of solving those problems. So this is from Chapter 7, Part 3. And I want to... got some questions about this via email, so I want to go over a couple problems similar to those that appear in the packet, but I won't be going over the specific problems that are in the grade improvement module, because those are ones you guys need to kind of figure out on your own, like big boys and girls. So here we go. First things first. It's really important that you guys understand. So this is called exponential form. Because as we know, the variable is in the exponent. That is compared to this, which is called logarithmic form. Why? Because here, your x is solved for, and the logarithm's on the other side. And so this leads to the frequent statement of logarithms are exponents. Okay, and that's really important, that when we talk about logarithms, we're talking about exponents, except normally when you multiply something by an exponent. Ramiana. Sorry, hold on just a second. Sorry about that, my dog was getting into something she shouldn't. So, on to problems. So, write each in a logarithmic form. So what we're going to do here is we're going to take the same information I just gave you, and we're going to apply it. So for number 1, we have 9, that's our base, squared, that's our exponent, equals 81, that's our answer. So when we write it in logarithmic form, we write log. What's our base? 9. What's our answer? 81. What's our exponent? 2. Okay, so it's the same process. Doesn't matter if we have fractions or not, okay? So here, log, what's our base? So the fact that we switch sides here, switch sides of the equation, doesn't matter. So here, our base is 1/4. Our answer is 1/64, and our exponent is 3. Okay? Number 6, so log, what's our base? 4. What's our answer? 1024. And what's our exponent? 5. Okay, that's it. So evaluate each logarithm. So what this means is, so we have log base 2 of 128. So that means, what do we have to raise 2 to? Not like the dance gear, but to TWO, to TO. So what do we have to raise 2 to get 128? Well, it helps here to know the powers of 2. So let's write them out. 2, 4. So we have 2 to the first 2, 2 to the second 4. 2 cubed is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. And 2 to the seventh is 128. Well, hey, look at this. So now we can rewrite 128 as 2 to the seventh. So now we have 2 to the x equals 2 to the seventh. Well, if the bases are the same and they're equal to each other, then the exponents have to be the same. So x equals 7. So log base 2 of 128 is 7. And what that means is that 2 raised to the 7th power equals 128. Hey, Bella, can you go pick up off the floor whatever Ramon's got? Thank you, sweetie. Okay, so number 10, a little bit more difficult. Why? Because if we look at 4, so it's up here in the top corner, write the powers, or the progression of powers of 4. Bellaboo, honey, it's your bedtime, sweetie. We have 4 to the first is 4. 4 squared is 16. And then 4 to the third is 64. So unlike number 9, where we had a very clear equality, 2 to the x equals 2 to the 7th, here we don't. But notice that we do have a common base. We have 4, which is 2 squared. Hold on just a sec. Okay, sorry about that. Where were we? Okay, so we have 4. So we see right here that 4 is 2 squared. And we know that 32 is 2 to the 1, 2, 3, 4, 5. So again, remember, if we have exponents to exponents, we just multiply them together. So we have 2 to the 2x equals 2 to the 5th. Don't forget Brea, honey. So here again, same base, they're equal to each other, which means the exponents have to be equal. So we have 2x equals 5. Divide both sides by 2. And we either get x equals 5 over 2 or 2.5. Either one's fine. Quick yawn, because as you can see, it's 11:30 at night, way past my bedtime. And yeah, so let's keep moving. So 15, I'm going to do 15, then I'm going to do 16. So 15 is a neat little rule. So if you ever see this setup, that's going to be your answer right there, 6. And let me show you why. Because what we're saying is 7 to the what power equals 7 to the 6th power? Well, 6. X equals 6. Now here, look at 14. So 14, there isn't a base. So hopefully you guys remember that when we're dealing with logarithms and there isn't a base, that base is 10. So here we go, 10 to the x equals 100,000. 100,000 is the same thing as 10 to the 5th. So we get 10, or x equals 5. Now, let's say, for instance, that we had something like that, log of 0.0001. Same idea. We'd go, well, 10 to the x equals 0.0001. So if you're paying attention, you know that 0.0001 is 10 to the negative third. Just negative fourth. So that gives us x equals negative 4. And remember, because if I have x to the negative 1, that equals 1 over x. Mama, leave Cleo alone. If I have x to the negative 2, that equals 1 over x squared. So if I have 10 to the negative 1, that equals 1 over 10, or 0.1. If I had 10 to the negative 2, that would equal 1 over 10 squared, or 1 over 100, or 0.01. Hopefully that makes sense. Remember how negative exponents work. So if you see a problem like that that has a decimal in it, chances are you're going to end up with a negative exponent. Likewise, so let's look at number 11. So what if I were to switch? What if the number that was the base was bigger? What would that mean? So let's say I had log base 27 of 3. So I'm saying, what power do I have to raise 27 to get 3? Well, again, knowing that 27 here is 3 cubed will help. So that gives me 3 cubed equals to the x power. So I replaced 27. 3 times 3 is 9. 9 times 3 is 27. So I replaced 27 with 3 cubed. I still have that x out there, so now I have 3 to the third to the xth power equals 3 to the first. That means I have 3x equals 3 to the first power, or 3x equals 1, or x equals 1/3. So that means that 27 to the 1/3 power equals 3, which is true because remember, if I have fractional exponents, that means that their roots. 27 to the 1/3 is the same thing as 27, the third root of 27, sorry. And that is how it is done. Hopefully that helped. You guys keep in mind, it's April 29th right now for another half an hour. Tomorrow's April 30th. You guys have it until the 4th at 7 a.m. to turn these in. So if you have any questions, go ahead, give me a call. Drop me an email, and I'll try and post something for you guys. Have a wonderful evening, early morning, and I will talk to you guys later.